Hello, hello. I'm so happy to have Scott Fulbright, the CEO and co-founder of Living Inc., with me today. It's been fascinating, Scott, to listen to all the stuff that you've been talking about. I had no idea that there's so much that goes into ink and dyes and things like that. I'm so excited to learn from you, from your journey. Thank you for being on the show.
Yeah, thanks for having me. Appreciate it.
So I'm going to actually dig into something which was we usually, we when we start chatting, we talk about, think of your childhood and think of something that influenced. And you spent half your Sundays recycling. And that's really fun. And I want to hear the story around that and how that influenced you. I'm sure everybody listening to it would be fascinated with that.
Yeah. So I used to be with my dad on Sundays, and he had a whole area, probably in the early to mid '90s, the whole cabinet area that would divide all the glass into colors, because at that point it wasn't a single stream recycling system. It was all the styrofoam and plastics had to be separated. So we would spend the week separating it out into bins. We would load the car up with all of the bins every Sunday, and then we'd go recycle every piece of material that was what was there. And I think that was one of those moments that was it just made it obvious to me, right? Like somewhere, at some point there was sand that had to be, removed from the earth to make glass. We used the glass. Let's put it back into the system to make another glass bottle so that we can do it again and again. And, it's one of those things that when you're doing that, it's just common sense, right? So I just never grew up in an area where we were using something and just, throwing it away right away. We really thought about what went in the compost pile, that we had in the back that was taller than me when I was a kid. I mean, that's how much compost we would then plant a garden using that compost, and then we recycled everything else. So I was fortunate to grow up with a dad that was pretty thoughtful and mindful, and the things that we would bring home from the grocery store, and actually making decisions on why would we buy this when it's covered in plastic when we can buy this and we can just put it into the cart. So yeah, that kind of set me down this trajectory of really thinking about the world and where things come from and where they end up.
Yeah, that was clearly early impressions and influences. And I want to actually interview your dad sometime. You know what?
Yeah,
Because that's amazing.
yeah.
It's not just recycling, that it's compost on one side and literally leaving a very, very low footprint. And that's so amazing considering the time. That it wasn't today we are so much more aware. And even now most of us are not doing that much about it. So considering that,
Yeah.
I'm sure it was an amazing just an amazing childhood to have that idea of being able to do it. But you also mentioned your grandpa being a crazy engineer, and how does that add up to this
Yeah.
equation of Scott being sort of influenced in the directions
Yeah.
that you were?
Yeah, I mean, going off of my grandparents, who I spent a lot of time with as a kid, and obviously raised my parents to kind of have the mentality that they have. They lived in the Depression era, so that was they were recycling for a lot of reasons besides just the environment. But hey, we want to save money. Hey, we want to use these materials for something else. So I was raised by grandparents where you had a little piece of aluminum foil. They would never put that anywhere. They would always put it back in the drawer and wash it and reuse everything that came into the house. So I think that that's also been kind of in my mindset to maybe to a flaw where now my wife's like, hey, we need to get rid of some things. We can't keep every bag and rubber band. Yeah, I mean, my grandfather was an engineer, so he built hydrofoil sailboats in the '60s and '70s, and he had a human powered boat where you'd pedal it like a bike and it would raise out of the water and go 20 miles per hour. So I was also fortunate to go around that kind of mentality at his shop.
Without an
And
engine? Sorry, I'm
I
interjecting. Without an engine, you could
yeah,
just paddle it and
no engine, no
wow.
engine. Yeah, no engine. We didn't really have engines growing up in our family. Everything was sailboats and human powered boats. And he used to get frustrated because if you had a sailboat and there was no wind, you couldn't do anything. You couldn't sail. So he said, I'm going to start making pedal boats, where you'd lay back like in kind of a canoe type boat and pedal it with your feet. And then it would go up to 20 miles per hour. It would raise out of the water. And he'd build a sailboat that had three sails and little floats on the side. And I always respected him because he always looked like that crazy inventor where you're like, I don't know that guy, but he is doing some crazy things, whatever he's doing over there. And it never, everything he did never looked like anything else anybody else was doing. And I always respected that. And I think that planted a little bit of my seed of I want to be a little bit different and do something that maybe no one else is doing right now. And so, yeah, it's fun to grow up in that kind of
And
world.
that's a great combination. You have a crazy engineer grandpa that just wants to do things which are totally unique and still work. And you have a dad, who, I'm sure your grandparents were as well, but you at least have a dad who's very conscious about the kind of impact we are leaving. And that I can clearly see the mix coming in you with, so many innovations as well as this whole intent of a positive impact on the planet. And I'm going to cut to another person who you mentioned in your talks is your grandma and the greeting card that created that impact. Is that really a true story, or you made it up?
Yeah,
That is okay.
yeah,
Super.
yeah. It's too weird to make up, I think. But yeah, no, it's buying greeting cards is again always my when I was in grad school, I was in Colorado, and my grandparents were in California, so I would always send mostly my grandma a greeting card, and she always liked receiving those, and so. Yeah, I just had one of those moments where I always kind of joke. There's these anecdotes of people having really good ideas in the shower, and I feel like for me it was the greeting card aisle where you spend all this time reading at your desk and in the laboratory doing science, and then of course when you kind of have one of those aha moments, it's in the greeting card aisle where you're not really thinking that hard, but you just have one of those moments of what am I surrounded by? What are all these colors and what are all these shiny coatings and where do they come from? And so yeah, that's where my kind of original idea came from, but also kind of connecting dots, like a lot of innovation, right? So right when I thought, where's all these colorants coming from in the greeting cards and packaging, it was petroleum, like a lot of the answers to our world of things that we use. And I remember a picture of the back bays of San Francisco where you fly in and there's these ponds of yellows and reds and greens and it's all algae. So, connecting a few dots of this is all petroleum. I know there's other colored, biological organisms like algae that have these colors. Could we combine those to make a really kind of renewable, sustainable colorant, for example? So that's how my breakthrough happened, which is kind of funny.
And you also seem to have spent a lot of time outdoors. You were like a sailing teacher. So talk to me more about, your influences of spending time out in nature and how that impacted your personality.
Yeah, yeah. My dad had a pond at his house, and my sister and I we had like an old pedal boat, and like one of those square pedal boats that go really slow. And we used to catch little polywogs that turned into frogs and catch frogs. And there's always algae there. And so, yeah, we spent a lot of time in the outdoors between the woods and the ponds. And I taught sailing every summer of my undergrad experience, both on Catalina Island out in California and then out on the East Coast on Block Island. And yeah, I just fell in love with the ocean and also just always so impressed with all these different organisms that we'd run into. You'd see like a little clear glob of material and you're like, is it a jellyfish? No, it's a ctenophore. And then you learn about ctenophores and it's amazing. I mean, like how advanced these organisms are, even if they're, pretty simple creatures in the end. So always was impressed, always wanted to use the biodiversity of what nature had out there in the marine biology setting and turn it into something that would benefit society. So yeah, spent a lot of time on the water. And I remember telling somebody when I was 18, like, I'm going to turn something like algae into something that's going to benefit society someday, having no idea what that means or how that path would go. But, here I am, probably almost 20 years later doing exactly what I wanted to do.
It's amazing how the universe collaborates. And so, where does this social consciousness come from? You just mentioned that doing something for society, and that seemed to be inbuilt in you as well. And was that also through growing up with people like your family, or was it somewhere else?
Yeah, I think it was a lot of family and probably a really good community that I grew up in of just people that were helping each other out always. And again, my grandparents, my parents, they're just the type of people that if you saw trash on the beach, you would just go pick it up, and they would carry it. I mean, they would take other people's trash and they would just carry it with them on a beach walk until they found the trash can and they throw it away. And so it's one of those things of why do you do that? I mean, I think you care about the community, you care about the ecosystem. And I used to fish with my dad quite a bit, and he would see a piece of monofilament, which is fishing line, and he would tell me, hey, this is plastic, this is not going to degrade anytime soon. He would almost risk his life at times wading across the river to go collect the fishing line that was from somebody else, put it in his pocket to then take it to the trash can. So, I think it was just kind of let's take care of ourselves. Let's treat other people, and let's treat nature the way that we would want to be treated. So, it's one of those things. I think just being raised, it's just instilled in me.
Yeah, you're just literally advertising, not even advertising. You're literally like, I have to plead in the end. Can I actually talk to your dad and meet him, because he just seems to be
Exactly.
such a clued person. Do you know of this organism called a water spider?
Yeah, is it the little kind of bug that kind of goes on top of the water and shoots
No, that's
around?
what
Is that
that's the
right?
water
Or
strider.
no, no.
So
Okay,
yeah,
Strider. Yeah, yeah,
so
yeah.
that,
Okay.
that
What's the
so I've
spider?
actually, so like, and this came to my mind as you were talking about the different things that you would observe when you were out on the water. And this is something that has fascinated me because I come from the background of packaging. So the water spider actually creates a web under the water, and it carries on its feet, it carries a bubble of air, oxygen, puts it inside that web, it procreates, it eats everything in that web, and it
Mm-hmm.
only needs to carry a bubble of air once a day, like once in 24 hours. And because it's obviously it cannot survive underwater otherwise. But what's fascinating for me, and I'm putting this in your head because, it's so that you can look it up and guide me more. It's what's fascinating for me is that what is this structure? And it's mostly amino acids, it's proteins. But what is the structure that it creates that webs so well that there is no water coming in, and yet it's breathing through it? But yeah, that's been my
Yeah,
fascination as
yeah.
well, to observe. Yeah, go ahead.
Can I ask you where did you hear about that? Did you see it in the world, or did you read about it
So
somewhere?
my master's, well, I didn't really finish it, but my mostly master's is in biomimicry,
Yeah.
and my whole
Oh,
intention
nice.
of
Okay.
doing
Yeah,
that
yeah,
was to focus on packaging. So I kept finding different, like I would look at the Alaska pollock. Alaska pollock has
yeah,
amazingly low air permeability, mainly because of where it lives.
yeah,
But the skin, again, collagens,
yeah,
how do they interact? And it's fascinating. And of course, I want to
yeah,
pick your brains a lot on the nature side because you mentioned that as well.
yeah,
And that's been something that's been so wonderful for me to observe and to actually see these wonders around us and just open our eyes. But I want to jump into marine biology in Michigan. That's I want that funny story that you talk so well in your TED. I can't avoid that one.
yeah. Yeah, well, it's funny because yeah, people were telling me I grew up in East Lansing, Michigan, which is where Michigan State is, and people, I think Michigan State's got a top packaging school. So I said I kind of decided I'd go to Michigan State because it was close to home, and for some other reasons. And everyone said go into packaging, and I said, I'm not going to do packaging. I'm going to do marine biology. And everyone said, you can't do marine biology means usually like the ocean, for example, which Michigan is in the Midwest of the U.S. and there's not a lot of ocean around there. There are lakes and rivers, and so that's where I kind of got involved a little bit of studying algae, and then ended up doing a project down in the Florida freshwater spring systems and understanding. I went down there for a month. We did field work every day collecting algae samples, where I'd be collecting algae and look over and there'd be like a manatee looking at me. I mean, just a really kind of fun experience of doing science and working really hard to collect the specimens to then, actually analyze the data. But we were trying to figure out why algae blooms were actually occurring. And that was one of those moments I said, the problem with an algae bloom is that the algae grows really fast. I mean, it just explodes in growth. And so that's when I and others really around the world said, can we use this for something that's beneficial? Like use it. The problem is it grows really fast. The solution is let's grow it for something that we can use it for because it's really good at growing. So that also set me down this path of the algae space and trying to use it. But yeah, studying marine biology and reading about opening up a textbook in the middle of Michigan in winter and reading about marine biology for me was a very big tease of like I wish I was at somewhere warm where there's an ocean right now.
Seriously, yeah.
Instead, I'm in a dorm room and it's minus 20 degrees. So,
Yeah, that's amazing. And it's so interesting that you mentioned manatees. I went on a wild goose chase recently. I was in West Palm Beach, Florida, and they have these
Yeah,
beautiful
yeah,
marshlands, of course, near them. And I went to see
yeah,
those as well.
yeah,
But I was like, I have to see a manatee, and just like they weren't there that day. It was too
yeah,
warm
yeah, yeah.
outside, so they didn't want to come to the power plant to get the warmth. So, I missed out.
They're finicky. They're finicky. That's for
Yeah,
sure.
that's definitely my favorite water animal. So I have to,
Yeah, yeah, yeah. They're
yeah, I
cute.
have
They're
to hang
cute.
out with them more. So how does algae? Of course, you've talked about it in part, but tell me more about how did algae happen to convert from an interest to something that you really wanted to work with? What transpired, and how did that happen?
Yeah, yeah. It's interesting. I mean, I think that I've always been, like I said, I grew up in the pond in the backyard where there was always algae. Learning about algae being the bottom of the food chain. That's a pretty instrumental thing to learn. That hey, the ecosystem has to start somewhere, and that really is algae going up the food chain. Going, swimming in California in kelp beds and realizing that's algae, and that's where there's a lot of ecosystem and a lot of productivity. So I've always was interested in it. When I wanted to get some experience in the laboratories as an undergrad, I got my first job where I was partially volunteering and partially getting paid to get started was at a algal ecology laboratory, and that's where I kind of dipped my toe in the taking samples, growing algae in laboratory environments. And, it's one of these things where if you see a flask of algae, like a little cup of algae that's really green, I mean, it really does intrigue me at least. And I think it's very, yeah, I start to wonder what's going on. I mean, I remember I got so into it when I was younger that I remember instead of going to the football game, I would go and I'd like do my work and I would count algae cells under this microscope because it was just fascinating to see things under a microscope that we just, it's already out there. We just don't see it because it's under a microscope. But you would see something come up and like eat the algae cell, then spit it out. That, it was just this whole world. And it was almost like a meditation where you'd like enter this whole new world. And I was still counting cells and doing my kind of job that I needed to do. But once I kind of looked under the microscope, I'm like, there's some really fascinating things going on here, and there's a lot of molecules, there's a lot of organisms that we might not even know about right now that could, still benefit society. So, really got interested in the biodiversity of algae and like how different some of these algae species can be. Right, you got red colors, you got green colors. It's mind blowing how much biodiversity is out there.
And just taking that forward, is that also different kinds of cellular structures, and where does the color come from? Is that pigmentation? What is it?
Yeah, there's all sorts of pigmentation. So yeah, if you get like a orange color of algae, that's like beta carotene. If you've got green, that's chlorophyll, like you'd see like in a leaf on a tree. So yeah, there's different pigmentation of the algae. Sometimes those algae are already those colors. Sometimes they're dynamic, right? You can have a green colored algae one day, and the next day it's red because it was starved of a nutrient. So as it goes through this dynamic environment, it can actually start to change physically. It can change color wise, but also like kind of the morphology can change. But yeah, I mean, you've got a bunch of different types of structures of some of these organisms. There's like little diatoms, which are basically little pieces of glass, for example. And you look under there, and I mean, they're just some of the most beautiful things of art you've ever seen with the diatom structure. So tons of biodiversity. Again, you take a sample from a pond, you look under there, you're going to see just so many different colors, structures, and things like that. And it really is art when you look under the
I would
microscope.
love to see more. Sometime I'm going to peek into, the probably drop by to your place and look into the microscope, because I'm sure it must be amazing. And like just this idea of these structures, which could be so fascinating. And in fact, one of the things, I was in a sugar plant about 3 4 days back, and they were showing me this big lagoon that they had for their wastewater, and they said, you know, it's the water is good because you can see algae grow, And I literally thought of you. I was like, I'm going to talk to Scott so soon, so I'm going to learn more about this. But it was
You know,
interesting that that
he
was their
needs that algae.
indication that, there's life. There's life
Yeah,
happening, which means my water is okay. And that was such a great
yeah, yeah,
indicator.
yeah. Yeah, that's really good, and it's funny. That is interesting. Going off the algae story that I just told, like the first job I got out of school after that ecology experience was growing algae for biofuels. And we would have these tanks of algae, sometimes these ponds of algae, kind of what you're mentioning at the sugar plant. And I remember, one of the people that I worked with there, who was a mentor of mine, she would smell the different flasks and tanks and ponds of algae, and she could tell you if the algae was growing happily and really productive, or if it was unhappy, right? If it starts to smell like grass, you'd go, oh, that's that's a happy algae pond right there. And if it started to smell like rotten or not good, you'd go, there's some degradation happening there. It's not going well in that tank. So we'd always kind of joke that there's all this science analytical equipment, and then she could just look at it and smell and go, no, this is good, this is bad. So
I did not know there was such a thing as an algae whisperer.
yeah, yeah, yeah,
This
yeah,
is
yeah,
this is
exactly,
she knows the
exactly,
feeling of
exactly.
algae. The other thing that came to my mind, my
Yeah.
youngest daughter is 7 now, and she was about 4, and she had learned this thing from me, and we would walk around forest, and she would go, Moss is the boss. Moss is the boss.
Yeah,
And it was so
yeah,
cute because
yeah,
she just had it in the mind because a moss can exist anywhere, and that was so fascinating.
yeah. I love it. I was actually walking with my kids last weekend and we saw some moss. We actually took a little bit. We brought it home and we planted some. And I was just telling my kids, I'm like, wouldn't you want your like bedroom carpet to be moss someday? Like it's so soft and green. So we were just kind of dreaming up things there. And the moss is still living, just a little chunk of it. And we're going to see if we can actually grow it to go, even wider and wider. But I like that moss. It's
Yeah, that's
beautiful.
amazing. And the other thing I taught her was, to squeeze moss and drink water from that. And she still does that.
Yeah,
So I don't
yeah.
know if it's so smart or
Nice,
not,
nice.
but she'll pick up moss and
I think
go.
it's good. I think it's good.
Yeah, so tell me, just going ahead with your education, and you went into this, and then I saw in our research, Qingdao Institute of Bioenergy. So what was that, and how did that help in your learning? And I'm sure just a year abroad or whatever time there was would have been very interesting. And China's, of course, very interesting.
Yeah.
And Qingdao, you get great beer. So, tell us more about that.
Yeah, you got it. You got it. Yeah, yeah. The beer capital of China, at least maybe the world. So yeah, no, I got a National Science Foundation fellowship to go study in Qingdao, and yeah, both professionally and personally, one of the best experiences of my life by far. Flying into a country that I'd never been to, I was the only international student there. So made a lot of great friends, and we would work really hard during the day together and teach each other the things that we had known. And I mean, that's one of the things I love about the scientific community is it's no one's holding back at those conversations, right? Everyone's trying to share everything that they know so that we can do more innovative things and really push the field of science forward. And I've always kind of respected that. It's been a hard transition to the business world sometimes where you're saying, oh, I got to value my time. I got to value my ideas, because in the science world, you're just kind of telling everyone what you know and how it goes and things like that. So we would play basketball after work every single day and then go eat, handmade noodles for dinner every single night. And yeah, one of the best times of my life for sure. But, it just opened me up to different resources, different perspectives. So I always thought it was interesting because when you play sport with somebody, it's no matter what language you're speaking or where you come from, there's a certain flow to the game of basketball, right? You can give high fives, you can smile, you can say, hey, I'm going to fake it, then you go. And I think science is very similar, right? We're looking at the same algae cells, we're understanding the fundamentals of how science works. And I kind of connected with a lot of different people there on those different levels. And I remember they showed me this one picture, and it was a picture of a strain of a little algae cell on a little tiny petri dish, and there was only algae where there was bacteria growing. And I remember, like, this was one of those moments in life that for me I was like, oh, like it just everything's connected, everything needs each other. And what we were finding out there was that there's certain bacteria that the algae would not grow unless there was certain bacteria present there. And so if you killed that bacteria, then the algae would not grow. And it's kind of like humans, right? Like in our gut, we've got, trillions and, billions and trillions of bacterial cells that are communicating with our body, and our health can be thrown off if that ecosystem within our gut starts to get thrown off, as we're finding. And so, there was just, I remember seeing that picture going, wow, that's fascinating. And that really kind of dictated the next couple of years of my life, and actually studying bacteria and algae and how they work together, or how they would, in some ways they would kill each other, in other ways they would help each other, and in sometimes it was just completely neutral and there was no really negative or positive to being with each other. So again, just showing how connected we all are as an ecosystem on this world of
Yeah,
organisms.
it's beautiful. It's so beautiful to see that it happens there as well with bacteria and algae, and that's fascinating. So I'm going to segue and move forward because otherwise we have lots to talk in that nature field. Anyways, and we'll come back to that. But then you go ahead and get a PhD in cell and molecular biology. You end up meeting Steve, and you guys then co-found this wonderful company, and you raised 60,000 on Kickstarter. So tell us more about founding the company. How did this idea of algae transpire into, yes, we can make a company out of this, and then then the initial stages of how you went about it.
Yeah, you've got all your information correct there. And so, yeah, I met my co-founder, Steve Albers, the first day of our classes during PhD. And we both said, let's use microbes, so algae, bacteria, yeast, to make the world a better place and to transition off of fossil fuels. And, you can come at it from different angles, but in the end, it was, coming from this world that we know we're going to run out of petroleum sometime and so we have to start transitioning off of petroleum. And so we would walk by each other in the hallways every day, and we would throw crazy ideas at each other. And we said, if you come up with 1,000 ideas, there's got to be one that you're like, maybe has something to kind of pursue, right? So we had a lot of bad ideas, and we would laugh a lot, and we'd have lunch together and talk about things we could do. And I remember I called him up after that greeting card experience that we already talked about on this conversation, and I said, hey, I got this idea. We can use algae as pigments and ink to tell really creative stories for sustainable products and packaging. And I think his response was like, I don't get it, tell me more. And I explained it to him, and he's like, oh, maybe, and we had so many bad ideas, we're like skeptical of each other. We're like, I don't know, like, well, and for me it was very clear and of what we could do with this. And so the first idea was to actually grow ink using light. So not even using energy or resources to grow to produce an ink, but to actually take a few algae cells, write a message, put it in sunlight, and actually see the ink grow in front of your eyes over days. So I could send you one of the products that we made, where on day 1 it would say happy birthday, day 2 a cake would show up, and day 3 it could say from Scott, and candles would show up. And the way you can think about this is almost like micro gardening, right? If you go to your garden, you plant seeds, it takes days and weeks to see those seeds pop up. But with algae, they're multiplying every day. So you would just kind of plant little tiny algae seeds, you can think of it. And then when they got exposed to light, they all started to, one cell would divide to 2 cells, it would divide to 4 cells. And next thing you know, you've got millions and billions of cells that are already kind of starting to tell a story and turn into an ink. And so we did a Kickstarter campaign, which kind of got us off the ground because we didn't have any, we're both, grad students and, pretty small stipends. And so we did the Kickstarter with kind of friends and family and other groups. And it was a great experience, right? Like, I think at one night I was going to bed and I opened up the Weather Channel to look at the weather, and I saw that there was a story was on us, and it was like, this company in Colorado is making this ink that would grow. So kind of gave us a taste of like PR and making a product. We learned what to do and what not to do, and we're still learning. We're still taking some of those lessons of what not to do and saying, remember, we already did that. Let's not make that same mistake again. And so we both had thought about doing like MBAs, and we said, rather than doing an MBA, let's just go build a business and learn how to do it and learn by doing. And that's what we've been doing really for the last several years.
It's amazing. It literally sounds like bromance at the first idea. Like meet on the
Yeah,
first day, start
yeah, yeah, yeah,
exchanging
yeah.
idea, and you're like, oh, you're my man.
Yeah, exactly. And the more I got to know Steve, I realized how smart he was, how innovative, how scrappy, and you start to identify these are people that I see eye to eye with, and I know we could do something special
Yeah.
together. So yeah, it's kind of a lot of luck
No,
and
that's
hard
beautiful,
work.
and you guys have stuck it out and building the company. So, how does it move from a
Yeah.
Kickstarter campaign to further raising funds and creating something that is actually marketable? And I know that you're already selling, so how did that MBA of life work
Yeah.
since you decided not to do an
Yeah.
MBA, which I think is a good decision. This is a better MBA. So go ahead.
Yeah. Yeah. So we started making this Kickstarter product. We sent those out, and with that product, there were some disposable items with the product, and we said, this is very fun from a creativity side of things. I think there was some kids that were doing it and really thinking about allergies. So in some ways, we were accomplishing some of the missions that we set out to do, which is get allergy into the world, make a real product, inspire, and develop creative products. But we also said we want to make an impact at scale that can be felt, from the climate and scale, to the consumer. And so we said let's not make an ink that would really grow right now. Although there's fun ideas of like a growing billboard where every day you drive by and you see the billboard change because it's actually alive. Like we had all these really cool ideas. Like, but what's going to make an impact? And so we said, let's set out to make a real ink that's a really high bio-based ink where the pigments are all bio-based colorants. And so I remember I had flasks of algae all around our laboratory, and one of my friends at the time was a designer, and he said, have you ever screen printed this stuff? And I said, no, I don't think you understand what we're doing. I don't think that would work. And he just said, take my screen, take my squeegee, and just play around with it in the lab. And so we started to just play around with that. And I remember it was pretty late one night where I just did a screen print, which is basically jamming, this ink, basic, very fundamental ink through the screen. And I pulled off the screen and it was this beautiful image. And I was like, oh, we actually have the ability to make a real ink that doesn't just grow and it's not just kind of niche. So again, kind of connecting a lot of dots, a lot of people were involved in that. But to answer your question, we got involved with an accelerator program through Colorado State University. And we applied, we joined the program. It was like a 12-week program. What's a patent? What's an LLC? Really the basics there. And then they also gave us $4,000. And at that point we're thinking, wow, okay, we've got some money now to kind of get some lights and get some algae. And that was really one of the seeds that set us in the direction to go do more and more.
And so my presumption is this hadn't been done before. Were there people who had actually created ink from algae, or it was an absolute new domain?
As far as I know, a completely new domain.
Wow.
Yeah, I had never seen anything like that. I think I remember seeing algae that had been really concentrated at one point in my life, where it was like a paste kind of material, almost like a toothpaste consistency. And I was like, oh, it kind of looks like paint in some ways, or, could you ever and I mean, I don't remember the time where I was thinking that, but I just, throughout that time, I think there's a lot of things that I saw over the years that just kind of added up to then starting to connect it and say, okay, let's do this. And by chance, my co-founder at the time for his degree was studying algae and cyanobacteria, and he was upregulating pigments to make different colors, so yellows and reds from these green algae. So once we got that ink idea, he goes, I'm already trying to develop these colors, so let's just make a palette of colors that are bio-based that can go into the world. So yeah, it's been a interesting journey of pivots and learnings.
Yeah, and how does so let's dig deeper into the actual technology and how does that work? How do you take a
Yeah.
bunch of algae and then, make it into ink? And then you just mentioned, and this was one of my questions that, do you just leave it as a natural color or do you put more dyes and make it into different colors? And I guess you do is what I'm guessing by the last comment. But yeah, would love to learn more about the technology itself.
Yeah. Yeah. So, um, So we basically take algae cells and we can upregulate different pigments in there. We can use the entire algae cell as a pigment, which is just a little tiny spherical cell full of pigments, or you can extract those pigments and you can get a really high dense colorant. And so we let the algae kind of grow those pigments, and then we can put those pigments into different ink formulations. So when you think about ink just at a high level, if you look at 100% of what ink is, about 80% of ink is things like water or vegetable oil or solvents or petroleum products. And then the other 20% are colorants. And the colorant is what gives it that color. So we knew that there was water-based inks. We knew that there was soy-based inks, which is that vegetable kind of carrier component. And everyone we talked to in the ink space said there's really not a lot of, none really bio-based colorants out there. So that's kind of that next stage of innovation in the ink space. And we said, okay, that's, there's a clear problem from what we're talking to in terms of there's no one else out there doing it. We have some know-how of developing colors from these bio-based solutions. Let's combine them. And I remember I went on LinkedIn back in probably like 2016, and I found one of our advisors, Terry Clayton. And Terry had spent decades in the ink industry, and he's just a magician when it comes to chemistry. And I called him up, and again, it's like when you find someone that kind of thinks like you, it's just like very energizing. And I remember talking to him the first time. I was in my kitchen, and it was like late one night, and he's like, "I love it. Let's do it. I love innovation. This is what I like." And I was like, he's like, "Send me some pigments and let's turn it into ink." And he was in his basement the next week, like going down his stairs at like late 11 p.m. East Coast time, and he's making up algae ink. And how he was really instrumental in getting us from a kind of a really algae biotech focused group to making real inks that could work in the world.
Yeah, that's beautiful. I agree with you. When you find some people who can encourage you in different ways, then you're just more inspired to do things. And yeah, it's just a little more. So you said something which was absolutely wonderful, which was trying to do it at scale. So how do you see that now? Like is that looking absolutely feasible, that you can take a bunch of algae, create this, add the right pigments, and create a whole bunch of colors? Where are you now with that?
Yeah, so good question. We basically are a pretty practical group of like, we're really sold on trying to make this happen in scale. And so we started to talk to some of our suppliers. So we work right now, when we scale up, we work with algae farms, algae companies that are already growing algae for various products. And they generate sometimes a waste product or a byproduct from their processing steps. And we can take that material and we can make our current black pigment. And what gets exciting about that is that we don't need a bunch of money or a bunch of time to scale up to get that algae supply. It already exists out there, and we can take that. So we've been able to scale that by taking that material and turning it into our black pigment. For the colors, we have been developing that in-house. We've got purples and blues and yellows and reds. It's all relatively smaller scale right now. So what we're doing at Living Ink is we've launched the black product. We're scaling the black product. We can make dozens of metric tons right now, with the goal of making hundreds of metric tons in the next year or so. And then the goal is to then launch colors after we nail the black product. What's fun about the black product is that we check the boxes in terms of performance. So it's really black. It doesn't fade under UV light. We're making ink that passes tests on all these different applications, which is difficult when you go into a global factory with a global brand that's a Fortune 100 company. They've got pretty high expectations in terms of performance. So super excited about the black right now. Colors is fun and it's challenging, and we do see a future there.
So colors is definitely coming. It's just a matter of time. And this is an absolutely basic question, and I presume the answer is going to be pretty straightforward, but you never know. It's a beautiful name as well, Living Ink. Was it difficult at all? Because all you've talked about, it seems pretty straightforward to me. But tell me about if there was any debate in what you should call your company.
Yeah, so I will give all the credit to Steve for Living Ink. He came up with that, and we have a very good relationship where we've always been good friends. We played soccer together, and we've had kids. We've raised kids the same age and had the same challenges and opportunities, and so it's yeah, he came up with that, and we just would brainstorm a lot. We'd always talk a lot because we're friends, and we'd have these conversations. And I'm not saying they were the most focused conversations sometimes, but sometimes that's where you need creativity, is you're just rambling and talking. And he was like, "We're making ink. It's living, and it's going to grow." And that was early on when we came up with Living Ink. The first name of the company was Grow Your Message, and we had this idea where people could kind of make their own message, and then they could actually grow it using that sunlight, like that first technology that I talked about. So we went from Grow Your Message to Living Ink, and we added technologies on the end of it because we've always seen ourselves as a true technology company, developing innovations, and turning those innovations into scalable products. So yeah, Living Ink Technologies. I'll give all the credit to Steve.
Super. And just on the comment that you made, and this question came to me before as well. So it grows when you have that sunlight exposure. How does it stop growing? And how does that happen? How do you ensure that that is happening? Because you don't want the whole paper to be smudged in the end.
Yeah, yeah, for that product. Yeah, so I'll be clear, we're not making that product actively at the moment, but the way that that would work is it was really amazing. It would only grow. So where the way that you could put it onto the paper, it was really defined line. Like it would never grow past where you would put it. So it would grow and multiply right where you put it, but it would never go kind of crazy or sideways or up or down. It just kind of stayed where it was planted. So we were always pretty impressed with how crisp that was for having a living organism. And yeah, I think yeah, it's definitely unique. And we went through a lot of marketing challenges there of like, how do you, if someone receives this, like what is going on? How do you tell that story? What are the expectations? If there's nothing there, we don't want someone to throw it away saying, "Oh, there's nothing on this." Like, no, give it some time, give it some light, So we had to put on a little label like, "Give me light, then I'll grow." Like,
Yeah, and it's beautiful in your TED talk when you show that owl thing, and it's just so wonderful to see that. And you did a whole time lapse on that. And I would encourage everybody who's listening to definitely hear your TED talk because just you're such a wonderful speaker and just keeps you totally centered. Like you don't want to even blink when you're talking. So it's so cool. Uh,
appreciate
but
that.
let's talk about the black ink then, and how do you see yourself in terms of course, you mentioned scale, but in terms of cost, are you able to come close to the petroleum-based products, or where are you? I'm sure that's a challenge that you're already facing, probably.
Yeah, it's a good question. Yeah, and so some of our products actually are at price parity right now. So we've got some screen printing ink in North America where we're at price parity or very, very close, depending on the specific product. We are more expensive than a petrol kind of pigmented ink out there. But one of the things we're working on is how to communicate this message to specifically decision makers within brands that, you know, one of the challenges for us as an ink company is we have to sell a lot of ink to grow this into a large company. Because if I sent you a drum of ink, you can print a lot of materials with that ink. So ink is typically by cost and by weight, a relatively small part of a package, for example. So we've been working with some of our printing partners and factory partners to really articulate to the brand. You might pay a little bit more, and when I say a little bit more, that might be hundreds, maybe thousands of dollars more for pretty large projects, and then you get to have a whole new innovation story, sustainability, potentially hit some of your carbon targets that some of these larger companies are mandating themselves to hit. So, I always like to make it clear to these brands that we are competing against an industry that's been around for 150, 200 years, that has very good technology, very good material. And we're a relatively small Denver-based company trying to play in the global space. So we're only going to get cheaper. We're only going to scale more and more. And so I like to make that clear. But we have launched with some well-known brands, and it's been digestible in terms of the pricing side of things. So I think that's also exciting, is that we're in the game, and we're going to get cheaper and cheaper and try to get down to price parity.
And what's your timing looking like when it comes to colors? And why do you, I guess I can see it from your uh, desire to do right, but why do you only want to stick to algae-based pigment? Can you not use other pigments which may not be as friendly but friendly enough to get more colors out earlier? And anyways, what's the timing if it is algae-based as well?
Yeah, well, that's a good idea. You should join our next board meeting and present some of these ideas. No, I like that. I mean, that's those are things that we're always thinking about. Like, what should we do right now? Should we go to market faster with some of these ideas? Are there other suppliers or partnerships that we can develop so that we're not doing all of the heavy lift of R&D and launching and scaling? So yeah, I think algae is a very sustainable material, and that's one reason why we like using this material. We have worked in other microbes, so yeast and bacteria, and we've been scaling up some of those kind of products. So we were flexible in that microbial space. I think from the other colorant side of things, some of these colorants come from potentially food sources where there's been some pushback there. And kind of like the biofuels, where we see some pushback, where it's like, why are we turning food into fuels, which is not always the case. So I'm going to make clear there, but that sometimes is. So we're open-minded to that. The way we see living ink right now is that we're replacing carbon black. Now, carbon black is the black pigment that's in, my iPhone case, my headphones, and even my pen, and it's what
all the
makes it
tires.
black, right? So right now, all the tires, exactly. So we even we see ourselves as as a carbon black alternative right now. So that's the focus at Living Ink. There's about 16 million metric tons of carbon black used around the world. It's a big market. It's one of those things that everyone goes, oh, it seems niche. And then you start to realize that, like, even my wallet here, like, that's carbon black that makes it black. So we're doing everything from rubbers to plastics to leather, to inks on shirts to then packaging ink. So we see a huge opportunity just within the black market. I think 40% of 40% of the ink market's black. So as we talk to some of these larger ink companies, they say, if you're going to start with the color, start with black, because that's where there's a lot of groups using black. Then start to bring on your colorant, your other colorants and things like that. So that's where we see it. But again, we do see the color as an opportunity, especially with the right partnerships, the right brands, and also the right applications. I remember, like, you can go out in the woods sometimes and you'll see some old can or piece of plastic and it's got the ink on there still, and you can tell it's been there for a long time. And one of the things that we're always kind of messing with in our heads at Living Ink is, how much do we fit into the expectations of the world versus try to set the expectations going forward, right? So when you see a box that gets delivered to me in e-commerce, it's got maybe glues or inks that are on there that are going to be around for hundreds, thousands of years, and it's an e-commerce box that got shipped right to my front porch, and I'm going to recycle it, compost it, or throw it away within a minute, right? So, we do see opportunities to tell stories and maybe innovate materials that tell the opposite of those stories, right? Maybe it goes away quickly once you kind of deactivate its use. And so that's, with the black product, we're fitting in. We want to pass all the trials, and we're playing that game. But every once in a while, we're like, hey, let's do something that's really different. Could you be drinking a Starbucks coffee or any coffee, and it's got a little sleeve with the logo on there, and as you're drinking that coffee, it starts to fade away because it's literally biodegrading. So those are those fun innovation ideas we have. Some of the marketers we talk to love those ideas, and then when you get into the real product developers and product line managers, they're like, I can't, I need it to be the way it is and the way it's been. And so
it takes an unreasonable man to make change. Well, man is not the right word. Human.
Yeah.
So my wife would kill me for that. My wife is a feminist infiltrator into her religion and stuff like that. Unreasonable woman enough. So as I see it, it's not. And when you say ink, it's a little broader. Then it's actually a dye as well, and you could use it for any black dyeing, at least for now, and then eventually moving into other colors.
Yeah, exactly right. Yeah, we're scaling the black. We've got a great source of material that's sustainably sourced. We've got a process where we've vetted all of the sustainability kind of metrics that are associated with the process that we use. So yeah, we feel really good about that. We hit all these different specs for all of these different applications. So excited to grow that. And then every single time we talk to a brand, they're like, and what about colors? Like, okay, we're working on it. But, when we talk to a lot of brands, they can always find a place to put black pigments. When you talk to any of these well-known apparel brands, for example, there's dyed products, there's inks, there's colored plastics and rubbers. And so, again, it's one of those things. We're working on like a little zipper right now with one of these brands. And so you start to stop and look around your world and you realize even the cord on my lamp here, it's all carbon black that's in that cord, right? So it's just everywhere.
Yeah, but like at least from my experience, customers would typically want a single source. They typically want to, like, for example, even in our business, we do have to use certain dyes for different colors, and I don't imagine, or I would definitely look at finding a supplier who does it all, right? The black and the red and whatever else is needed. So I guess that might be something
Yeah,
that your
yeah.
customers will keep pushing you for, and I guess they're already doing that.
Yeah, they ask about it. We're making product that can really, black is one of these colors that can really be printed with a lot of the other kind of cyan, yellow, magentas, for example. So every brand, every ink company might have a little bit different cyan color or maybe a little bit different magenta color. But in the end, the black
Yep.
is a black ink. And so we really fit those specs. And so whether you're using somebody else's colors, we do see our black fitting in there. But yeah, I mean, the end goal is cyan, yellow, magenta, black, because if you have those four colors, you then can start mixing and making different colors. And so that gets into the nuanced conversation of, can we make a specific Pantone color using the bio-based colors? And so that's a different conversation. The four colors I just mentioned, CYMK, we do think there's an opportunity to kind of dial that in and make a pretty high quality
Super.
product.
And what's been fascinating for me in listening to you is also the deep focus that you guys come in with, because there's always that temptation, and you've mentioned a little temptation here and there of bacteria and yeast, but it seems to be a very narrow domain that you guys are so focused on inks, and within that, well, algae, and then inks, and then within that black, and let's get this right. Where does that emanate from, and how do you stick to that? Because I'm sure you also talk about curiosity and ideas, and I'm sure those are coming by the
Yeah,
millions. So how do you manage to, have these two sort
yeah,
of, it's a dichotomy, a diatomy, where
yeah, 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 yeah.
you're struggling with so many ideas coming to you, but yet sticking to the path and making this work. So how does that work for you?
Yeah, I think we're just extremely focused on succeeding in what we've set out to do with the black inks and pigments. I am curious. I like taking on new challenges, and so my production team and my R&D team will kind of pull me aside, saying, "Hey, let's slow down and saying yes to all these innovative projects. Let's get really good at what we're doing right now." And make sure that we're driving the business forward, knowing that we can have our own innovation arm to do these future looking things. So my instincts is to always say yes when someone says, "Do you want to do this project?" I'm like, "I absolutely want to do that project." And then I have to go, "Let me think about it. Let me talk to my team and we'll see if we can do it." So, we've done a couple projects where we've had companies sponsor research where we said we don't have the time right now, we're focused to do that. But if you want to sponsor some research, we'll definitely get someone dedicated to that specific idea or technology, and we'll work on it. So we've done some of those very successfully, I think, from both sides, our side and the sponsors. So I think it's difficult because I read something in the news and I go, oh, like someone's turning algae into cement. Well, we could try to, that sounds fascinating, right? I'm like, okay, stay focused. If we're successful here, which I think we will be, there's going to be plenty of other opportunities to innovate off of this idea or future ideas, I
Yeah,
think.
that's brilliant. I think that's your MBA right there. Like,
Yeah,
if you
yeah, yeah.
can stay focused, I think half the battle is won. I think we get so attracted by ideas, and uh, you know, two sort of different things. One was that I was banned from coming to our production machines at one point from our team because I would want to experiment on those machines, and they're like, "Dude, we need to produce and get profits, and stay away from the
Yeah,
machines." And then, of
yeah,
course, then that's the other flip side where we've literally fixed our thoughts on we're going to use agri waste and create compostable packaging. And then again and again, our innovators would come in and say, "Oh, let's do this. Let's go outside this market." And I have to keep, no, 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 no. These two are fixed. We are not moving those two goalposts, and then everything else is in between. And but it's such a struggle, right? There's always so many great ideas that people come in
yeah.
with.
Yeah, I hear you on that. And I think that sometimes you get, if you step outside those goalposts, sometimes you get rewarded, right? And sometimes that can be a good thing. And sometimes it's a bad thing because then we start to say, well, what else are we missing? What else am I saying no to that is a huge opportunity that I'm being so laser focused right now that we're not even paying attention to? So it's that fine line between being innovative and exploratory, while also staying focused and closed minded. And I think that's a really challenging, for any company, especially in the science space or doing true
Yeah,
innovation.
but I am going to make you defocused a little bit because I want to learn more. So tell me a little more about how does algae turn into biofuels and animal feed, and does that, do you feel that has a future as well?
Yeah, I think there's a future there. I think there's been a lot of sponsored projects by different agencies, really around the world, from the Department of Energy to the National Science Foundation, who are, really uh, driving the algae sciences forward. I like to remind people that when we think about corn or potatoes or soy, those kind of crops have been around for 10,000 years, right? We've been breeding those different organisms and learning how to grow them. And when you think about algae, it's a relatively new crop in terms of how to grow it at mass scale, how to do it cheaper. So there's a lot of good research going on by various companies and universities around the world. So I think there is an opportunity to grow into these different sectors. I think there's a lot of smart companies right now who are starting off doing kind of the high value products like cosmetics, for example, and food products. And kind of building the company there, knowing that the phase two of those businesses are probably to go more into the commodity space and industrial space. So I think there's a great opportunity there. The way that it really works is that these groups can grow algae in things called bioreactors, which you could think of as like glass tubes or bags, or you can grow algae in a pond. So think of a kind of an oval pond that's about 8 to 10 inches deep with a little paddle wheel that just kind of moves the river around in a very light flow, like a little river. And the algae multiply every day. So the algae grow, and then you harvest the algae. So you could do that by spinning it really fast so that you concentrate it. And there's other kind of filtration techniques to basically remove the water from that algae. And then you've got this kind of paste-like material that can go, you could dry it, you could extract things from it. So when we think of fuels, one of the ways people have thought about doing this is growing algae, extracting the oils that are already within those cells, to make a biodiesel, for example. And so, you could take the waste from that product and you could actually potentially feed it to aquaculture and feed animals. So, there's a lot of opportunity. It really comes down to getting it into the world and figuring out where those challenges lie in terms of the scale up and the actual product. And I think that's something that we focus on at Living Inc. is let's make a real product. Let's get it into the market. Let's get the feedback and then keep iterating on the innovation to make it work. So, that's high level kind of the algae
Super
industry.
fascinating. I do want to throw a little more light on the environmental impact side, and just for the listeners to learn more about how ink, what is ink, and you mentioned it a little bit before, but maybe expanding a little more on that, and the kind of impact that it has, and of course the difference in, because this is like a carbon negative product, and how does that differentiate, and then the overall end of use, end of life impact.
Yeah, so there's about 16 million metric tons of carbon black used around the world, as we mentioned, all the rubber applications and inks and beyond. For us right now, where we're focused on that application specifically, we could remove about 100 million metric tons of CO2 emissions per year. I believe it's an order of magnitude larger than like Chevron's Scope 2 emissions. So it's definitely impact. There's significant contributions that we can make as we scale this to remove CO2. I think it's a really interesting idea to produce carbon negative materials because the way that I was raised of kind of not consuming things or recycling things, when you start to develop a carbon negative material, the more of it you use, the better. So we have some of our customers who are like, add as much pigment as you can, because that's where we're seeing the carbon negative attributes. and we'll say, okay, we can do that. It might be a little bit more expensive. And they say, that's okay. We want you to use the carbon. We want you to use the pigment so that we have more of a carbon impact on our product. So those are encouraging conversations where the more of a material you use, the better from an environmental standpoint. In terms of ink, I think there's about 9 billion pounds of ink produced every year. And so, it's, I should have some fact of like how many swimming pools that is, but it's a lot. And it's one of those things that you look around the world again, and you go, oh, it's everywhere. I think there's significant improvement we can make within those industries. And I think there's, from the climate change standpoint, we can make a lot of impact. I think it's probably secondary to the cement and steel and some of those really big industries like fuels and things like that. But we see a huge opportunity to make an impact on the carbon side of things.
Super. And how are you seeing the traction with customers and markets? Who are the initial takers? How much are you now? I presume you're already manufacturing and selling. So what is the regular kind of role and traction that you're getting?
Yeah, we have a production team. We have a great production team. We've got production manager. It's been fun to kind of build that out. Quality control, on all the products we make. I think what's interesting about what we're doing is that we're making these different pigments and inks for all these different verticals. So, we do packaging, which is a very different market than making a shoe, which like last week we launched our first shoe with Nike where they actually used our footwear ink on the shoe, which is very different from a product that we sell into the leather industry, into the plastic industry, right? So, we work with a lot of different groups, a lot of different partners in those different verticals. A lot of it starts with the brand, right? When a brand like a Nike says, we want to do this, and they, ask their factory partners to work with us, that's really where a lot of this customer pull through happens. We then work with like a Nike factory, for example, and we kind of say, what are you trying to do? What are the specs you're trying to hit? And we see if we have a product available. And if we don't, then we can say, well, maybe we can make a tweak to one of our existing ones and we can send something over. So we're getting some consistent factories who we got a partner out of Colorado called Eco Enclosed that does e-commerce. They're one of our consistent customers where they offer us to a lot of their different existing and future customers. And we've probably printed 50 million units with them over the last couple of years, and we're just kind of one of their standard products that they use. And so we're starting to see some mass adoption within these brands as well, where it starts with an initial trial, goes to kind of a pilot, and then that's all of a sudden we're doing tens of millions, if not more, within a brand.
Yeah, that's wonderful. And of course, it was our wonderful conversation with Saloni, and that led to your introduction. So of course, Eco Enclosed was wonderful. So one of the things, Scott, that I've struggled with in the past is the challenge of we can create great products, but the process of creating those products also has to have a certain amount of impact. And at least the industry that I come from, yes, the product is good, and it probably is lesser impact when it comes to process to a fossil fuel kind of product, but it's not ideal still. It's not nature. It's not, the trees are just sequestering carbon and building these sugar cells and cellulose and whatever. And, we're not yet doing that. The only source of energy is the sun, and, the story. So how is it in this case? Are you in the process itself? Is there a lot of energy and heat that needs to be used, or are you able to mitigate that significantly?
Yeah, I think a lot of our impact starts with the starting material. So using a sustainable sourced material. When we work with these different suppliers of algae, for example, they're consolidating that source of material in one spot. So, we're using a waste stream, and that waste stream is a consolidated waste stream that comes out of a single area. And I think that's different than, there's been projects in the past that say we're going to go up into the mountains of Colorado and collect the dead wood from a beetle kill disease, and then we're going to come process it. Well, by the time you spend all of the energy and carbon to go retrieve that material, it's already, as you mentioned, it's already not really even better than using just petroleum. So I think we've opened up our mind to that a little bit of it has to be good for us to do this. And, one of the breakthroughs that we had in this process is we said we don't want to scale anything that's not going to be better than petroleum. And in the end, petroleum is not great, but it's getting pulled out of the ground, and it's they make high quality products, so it's tough to compete against. But we did a full life cycle analysis looking at carbon emissions with Colorado State University and one of the professors there. So we did all of this work to collect this data. We gave that team the data, and they crunched it, and then they're the ones that have come up with kind of giving us this negative carbon metric with our process. And that was one of the more exciting days I probably really had in my career, which is, okay, not only can we make this, but it actually is beneficial, and we are using a waste product that typically gets incinerated or dumped into the landfill. You start to combine those stories. And that's when we said, okay, let's make a go at this and really scale it, because we've verified that it is better than using a petroleum-based pigment and ink. So we are still using energy. We're still handling material. We still are moving material around. It's just that when you have a carbon-negative material, you're actually sequestering more carbon than you are emitting during that manufacturing and processing of the material. So you're spot on. Just because it's bio-based doesn't always mean it's good from the carbon standpoint, for example.
I'm just going to pick your brain totally randomly, and this is for selfish interest. So, of course, I'm totally inspired by nature when it comes to packaging. And what we see is fundamentally two building blocks. It's amino acid and some hydrocarbon chains, sugars. Those are the two building blocks. You have some minerals and a little part of the periodic table that goes in. So with your eye for nature, do you find any inspiration, and do you think that can be used in terms of adapting to the packaging side? And in particular, what we really struggle with right now is flexible packaging. It's like barriers, and nature has that. We have so many wonderful barriers. It could be the lotus effect, and all of that. But to actually put it in industry and replacing something which is so dense when it comes to stopping air and moisture, and of course nature breathes, and so I don't know. It's a totally random, but it's just trying to pick your brains for selfish interest. So do you have any thoughts there?
Yeah, yeah, yeah. I do have some thoughts. I've seen some materials that I like out there that are using like agriculture waste, like you mentioned, and it's funny because when I walk the beach with my kids, we're always picking up. We talked about moss already, but we're always picking up little pieces of kelp, and when you see some of the macroalgae or seaweed out there, you see those little, almost like little pods full of air. And I'm always like, could we use this as a source rather than using styrofoam? Could you just use these little pods that are macroalgae? And so, one of the things I always do, and my wife would complain a lot, is that like I always bring that stuff home with me. And she's like, what? Why are your pockets, and why does your car have like all these random things from nature? But I always want to see how they're going to persist, right? And I think one of the things that I've seen is that nature needs moisture a lot of the time, right? So when you see like a little kelp leaf, for example, and it's wet, it's super flexible, it's super robust, and then, you let it dry out and it becomes more fragile. So, Steve and I have always been kind of thinking about how do we use biomaterials where we can develop technologies to help kind of keep that moisture there. And I think there's ways to do it. I think some of the challenges I see as we start partnering with global manufacturing partners is just kind of like you said, like you're an innovator and your production team didn't want you near the production, so how do you take those ideas that are maybe a little bit different than how you would normally run a facility and start, implementing those into the real world? So yeah, there's the innovation step of things, and then there's that real world application side of things. So yeah, I'm always thinking about those things. I don't have any major solutions in this conversation, but I love the macroalgae type idea. There's 25 million metric tons of seaweed down in Florida and Puerto Rico that gets washed up on the shore. And, we're not the only ones looking at that material. There's a lot of groups out there saying, what can we make with this in packaging or cosmetics or anything like that? So I think there's potential, but that's where, people like you and I need to chat more and develop
Yeah,
those
I don't know
ideas.
about you, but I'm definitely getting you to one of our board meetings just to pick
Yeah,
your
yeah.
brains and to show what we are doing. And another fascinating thing which you would love. is that so we also produce a lot of pulp and paper from agri waste. And typically, what happens in a paper machine is that the natural tendency for the fiber is to orient itself at about a 25-degree angle as it's moving. Uh, the water is getting drained from the fiber. So the difference, and of course, then you look at sea kelp, which is fundamentally cellulose, but it withstands the worst of the storms in the ocean, and it just moves with this beautiful motion. You know what it is? At least that's what I've found. It's only the degree at which the cellulose is, the fibers are based. It's 60 degrees. And it just makes it much more elastic. And that's again the wonder of nature, right? It's that little thing which, so I'm sure there is some way to orient from 25 degrees to 60 degrees and see. We just haven't gotten to it yet. But see kelp, that's what it does. 60 degrees.
Yeah, yeah, yeah. No, I mean it's fascinating, right? I mean, I think that one of my, you've been in the world of biomimicry, but one of the first moments I was like, back in Michigan when I was studying marine biology on those winter nights. I remember getting to the back of the book and it had a picture of mussels. Right now, mussels can stick to those substrates under massive storms. I mean, you can't even you take a screwdriver, you can barely get a mussel off the bottom of a boat, and you're like, there's got to be ways we can use that for a sustainable packaging applications, for example, right? It then comes down to all sorts of the physical, the chemistry, how do you make that work? But that's where I want to dedicate my career, is like translating those, like you mentioned, the degree at which the cellulose is to something that's useful. So yeah, nature's fascinating when you start taking a
And
look. That's
the world needs you, Scott, and your mind and your effort. And I hope that it keeps going. So that takes me to my final two questions, which, of course, are always something that we love to hear about. So, if you look at living ink, if you were to take a time spectrum, and it could be 5 and 10, whatever you think is long enough, and you have mentioned this a few times in terms of scale, but what would be an ideal desire? That how would you see living ink moving in the next few years, whatever timeline you want to take?
Yeah, I mean, our plan and our dream is to scale the black pigment and ink products to millions of metric tons, while launching the colorants, so the cyan, yellow, magentas, and the various applications that we want to work in, while having a true innovation program. And I think that's always been our dream, is like, how do you have a financially sustainable business that's successful enough to start funding our own R&D, just from a curiosity standpoint and trying to make things happen. I mean, that gets us really excited. So the idea there is to innovate other technologies that can be launched into the world. As you mentioned before, we don't have a lack of ideas. We have a lack of time and money and people and things like that. So yeah, build those resources up so that we can really hit hard on some of the things that we're talking about, like a macro algae packaging material.
Yeah, do keep working on that packaging side. That's definitely needed. Okay, so the last one. What does good garbage mean to you?
Yeah, that's a good question. I think good garbage for us, and the way that we've always been thinking about living ink from the first time we ever made an ink that would grow is, can you put together materials that you could drop on the ground anywhere in nature or in your house, and and it ends up doing two things. One is having a very neutral effect on the world, or two, actually benefiting the ecosystem in some ways. And if you take our black pigment and you dump it in a crop field or you dump it in my backyard, that pigment will actually beneficially affect the grass or the plants to grow. And I think that's what gets us excited, is can we get a material like that in all of these different materials, from the substrate to the glues to the pigments to the other ink applications. And I think that's what good garbage means to me, is replenishing the ecosystem rather than polluting the ecosystem.
That's beautifully put, Scott. And it's been such a joy to talk to you. I just saw the time now, and I was like, oh, that time is really flown. And I love your curious brain and the purity of soul that you come from. And with that, the mix of focus, and that's really a potent kind of mixture where you. I just wish you all the best, and I feel that Living Ink is going to make a big difference with this great mix that you have going. And I look forward to more and more success for you. And of course, I look forward to learning more from you. Thank you for taking the time and being on the show and sharing all these wonderful ideas. Thank you.
Yeah, thanks for having me and listening to all my stories. And I really look forward to staying in touch with you and continuing to innovate within the biomimicry world and make sustainable products. So thanks for having me.